In this slide, we will be solving a golden section search example. And in here, you can see that this is our function. And we want to find the minimum of this function. And the interval, so we will use golden section search. And the interval will be x lower is 0 and upper is 4. And initially, we need to find the golden section ratio, the d value actually. If you remember, we will first start with the creating of the two interior points, but for that we need d value, and d was root 5 minus 1 divided by 2, which is the golden ratio, and xl minus xu minus xl, and these are known as 4 and 0. So from here the d value is 2.4721. Let's use this to find the two initial guesses. The first one is x1, and we are finding it by using xl plus d, or d plus xl, and it is 0 plus 2.4721, which means 2.4721, and also x2, and it is found by xu minus d. This is the formulation. It is 4 minus 2.4721, which gives us 1.5279. Then we will calculate the function values of these. So if we calculate f 2.4721, if we write this into here and here, the result is minus 1.7647, and f 1.5279 becomes actually this is the opposite. This 2.4 gives minus 0.63, and this one gives minus 1.7647. So fx2 and fx1. And we will check if fx2 is smaller than fx1. Here you can see this is fx1, this is fx2, and we check that fx2 is actually smaller than fx1. That's why we will have the best estimate as x2 with the value of fx2 minus 1.7647. So in other words, whichever is smaller, we will just use its value as the estimate or minimum. Here fx2 is smaller, then we will use x2. Let's move here. Then minimum is at x2, which is 1.5279, and with fx2 minus 1.7647. Then where is the interval now? We will just use the interval of, so the minimum is in the interval defined by, so because we define this x2 by the upper bound, we eliminate the upper bound and set x1 as the upper bound, and that's why the interval will be defined by xl, x2 and x1 as xu in the next iteration. In the next iteration, we can say. And here, actually, this is not the minimum, the estimate. We will have an estimate of the minimum here, but this is not actually the one because we will continue to the iterations. So for the new iteration, actually this was I equals 0, then I equals 1. Lower bound remains the same, xl equals 0, and x1 becomes the upper bound, xu equals x1 equals 2.4721. And the x2 that we determined here as the estimate will be x1. So because it's closer to x lower bound, actually, we changed xu, and this x2, that's why it becomes the x2 becomes x1. Then x1 in this iteration will be x2, which is 1.5279. And we already know about the function value of this. We don't need to calculate it again. Fx1 equals f1.5279. We already know this as minus 1.7647. So I wrote here for I equals 1, the next iteration, the values. Now all that remains is to compute the new value of d and x2. So let's calculate d again. D was root 5 minus 1 divided by 2, and xu minus xl. And again here xu is this time 2.4721 and xl is 0. Then from here 1.528. With this we will find x2 again, because we already have x1, we don't need to find it again. X2 is basically with the new xu. Because xu changed, we need to change x2 because the formulation is based on that. Xu divided by d, and that is xu is 2.4721 minus 1.528, actually 1.5279. Let's use more digits. Then x2 is 0.9443, and let's calculate fx2. F 0.49443, if we calculate it from the function, minus 1.5310. That's the result. And let's compare now fx2 and fx1. You can see that fx1 is still fx1. This one is smaller. So let's write fx1 is smaller than fx2. Then the minimum estimate is fx1 or x1 minus 1.7647, and fx1 is, sorry, not this one, this is the function value. Fx1 is actually 1.5279, and fx1 is minus 1.7647. Now the interval is done for I equals 2. This time we will change the xl value because we determined that x1 is the minimum estimate, and we actually determined this using Excel. That's why we changed the Excel value as the minimum, the value of this. Then Excel, actually we can say this way first. We can write the same. So the minimum is in the interval of x1, x2, and xu, and x1 will be Excel here. So in iteration 2, our Excel will be x1, which is 1.5279, and x2 becomes x1. Actually, we will find x1 with the new value. That's why x2 becomes this now, because we have x2 again. Let's write it down. Yes, actually here the x1 is not x2, because x1 is here 1.52, but x2 is 0.9. So x2 is smaller. That's why the smaller one will be the lower bound. So let's change the order of these. We will remove XL, and the new minimum one of the x values will be lower bound. So it will be x2 will be XL, then x1 will be a point in between, and also there will be xu, which is from the previous iteration, from this iteration. So then in I equals 2, we will set, let's remove this, the lower bound XL is equivalent to x2 as we said, and it is 0.9443. Then we also have xu as the same, which was here 2.471, so it's the same 4721, and we will calculate an x1 with the new XL. That's why the remaining x1 here becomes x2 here. So we don't need to calculate x2 again. x2 is x1 is equivalent to x1 is 1.5279. Then from here we will use d root 5 minus 1 divided by 2 and xu divide minus xl. So 2.4721 minus XL is 0.9443. Then we will use this to find x1, which is equivalent to d plus XL. When we find these, we will have again 4 values, and continue. Check the function values of these. Which one is minimum? Depending on that, we will repeat this process further and have the results until convergence actually. And for the convergence, we need to check the this minimum estimate value of fx, for example. If it converges, then we will stop. Let's check these in the following slide in a tabulated way, all the iterations. In this slide, you see all the data during the iteration up to 8 iteration. You can see here, and the current maximum value is highlighted for every iteration with blue. And you can see that, for example, in the first one, we had x2 and x1. Then based on those, we will calculate fx values. And in between these, this is smaller. Then we will take this. If we take this, that means we will take this actually. And that means we will eliminate xu and make this x1 as the new xu. And if we continue in the second one that we calculated in the previous slide as well, the x2 was calculated as this one, and x1 was the previous x2, and xu is this. Now let's check the function values. This function value and this one, this is smaller. Then our next estimate of minimum is this one. In that scenario, we will remove the lower bound and set the x2, this x2 as the lower bound because it's the smallest one. We will check these, which one is the smallest, this one, then set it as lower bound, and we know the function value of that. And this x1 here becomes x2, so we simply change it to x2, and we calculate the new x1 here using the new xl with the d value that we calculated from the golden ratio. And here again we compare the results. Let's check the function value of this and this. So this is minimum. That means we will use this as the minimum estimate. Then we will have this and the lower bound and the x1. So we remove the upper bound. That's why we change the upper bound here. And we continue like that. We actually set this x2 as the x1 and calculate x2. We actually found the xu new. So we will calculate x2 from the new xu using the golden ratio. Then we will check the function values again in the fourth iteration. You can see this value and this value. This is smaller. Then we will take this x1, remove xl, set the new xl as x2, and keep the xu the same. That's why, because we actually modified this, we will need to find x1 from the golden ratio and continue like this. You can see that the function values are actually converging, and this is very small compared to the previous one, maybe this one as well. So eventually, in the end, after 8 iterations, the maximum occurs at x equals 14427, this one, with the function values 1 of the 1.7755. So the result is converging on the true value of 1.7757 at x equals 1.4276. If we continue further, slightly further, we will be able to get these as well. And you can see the difference is very small even at the 8th iteration.